All right, guys. Let's talk about 5.4, 5.6, and 5.7 in terms of review for our Unit 4 test. Okay. So first off, these first four problems, it's just simply exponent work. And when you divide like bases, you subtract the exponents. So for like number one here, we have, because I have 3 to the 14th over 3 to the 5th, this is going to simply be 3 to the 14 minus 5, which is 3 to the ninth. And most of the time, when you're working these types of problems, you're not really being asked to simplify, like find out exactly what 3 to the ninth is. You're just being saying, all right, go find 3 to the ninth. So for instance, like on number two, you have 5 and 7 raised to some power. And so you're just simply going to reduce those powers. So you got 5, 9 minus 6 is 3. So 5 cubed times 7, 12 minus 8 is 4. And so that would be your answer. Like, there's no need to uh, figure out what that number actually is. It's actually a really big number. So there's that. Um, now, anything raised to the 0 power is 1, but you need to remember that anything, the power is only applied to what it's attached to. If it's attached to a number, it only goes with that number. If it's attached to a parentheses, it's everything in the parentheses. So on number 3, notice the difference between 3 and 4. 3 doesn't have a parentheses, 4 does. So it's going to play a key difference in that 12 to the 0 power is going to go to 1. But that negative is still there. So you got negative to the 1 times 1, which is -1 for your answer. And then here, 0 applies to everything, including the negative on number 4. So this is just 1. So it's a subtle difference, but it's one that's important and will keep you from getting the correct answer if you're not careful. Okay. When you raise a fraction to a power, you give it to both the top and the bottom of the fraction. And so this is going to be -3 cubed over a cubed. Right? Obviously, there's nothing I can do with the a cubed, so it'll just go straight to my answer. And then I need to figure out what -3 cubed is. And because I have an odd number of negatives, because I have an odd power, the negative is going to stay negative. And so that's going to be -27 a cubed, or -27 over a cubed. All right. Um, I think it's a good practice on problems like number 6 to remember that exponent of 4 goes to everything. Now, when you raise the power to a power, you multiply, and that one's pretty straightforward. But here's what I would recommend you do. If you see a number like this, I would just take a step, and let's say that's going to be 5 to the 4th, and this is going to be x to the 12th, and y squared. Take that step, and then figure out what 5 to the 4th is. 625 x12 over, that should be y to the 8th. 2 times 4 is 8. That should be y to the 8th. Okay. Now, again, you're not really going to have to guess on whether or not to simplify your answer. Like up here, we didn't really simplify our answer. We just applied the exponent or simplified the exponent and moved about our day. Here on 5, 6, and so on, we're actually going a little further and actually getting the number. You're not going to have to worry about whether or not you're going to have to do that because of the multiple choices on the test. So just keep that in mind. Don't stress about that. So here, let's take a quick glance at this. I have 45, which is bigger than 5. I have x to the 10th, which is bigger than x cubed. I have more y's on top, more z's on top. And so when I reduce this, I'm not going to have a denominator at all because everything on top is bigger than what's on the bottom. So once I see that, I can just go item by item. And so 45 divided by 5 is 9. X over 10, x to the 10th over x cubed is going to be x to the 7th. And then you're going to have y cubed. And then you're just going to have z. When the power is 1, you don't have to write it. Also, it's understood. If you don't see it, it's understood to be 1. Okay, and so there's that. All right, here, I'm going to have -1/2 from the -6 over 12, and then I have more x's on top, so that's going to be x to the 4th. And you can leave it like this, or you can say x to the 4th over 2 and make it negative. And remember, because this is a simple fraction, I can leave it. I can put the negative out front, up top, or below, and it's all the same. So just be aware of that. Now, for problems like number 9, 10, and 11, you are dividing. And so you're not going to take a GCF out. You are going to take a common factor out, but you're not going to take necessarily the greatest common factor. Sometimes it is, sometimes it's not. Sorry. But we're going to take out an 8 out of the top so that I can get rid of my denominator here. So when I do that, that's going to be 8 times 3 is 24. So that's going to be 3 r to the 6th. 8 times 5, so it's going to be 5 r cubed. Remember, I could take out, if I'm taking GCF, I could take out an r, but it doesn't help me to take out an r here. I'm only just trying to get rid of my denominator. So I'm only to take out just enough. All right, so now I can get rid of my 8, and my answer is 3 r cubed, or sorry, r to the 6th minus 5r cubed. Okay, easy peasy. So it's essentially telling you what to take out. You just have to be careful enough to take out everything correctly. So on top one number 10, I'm going to take out 8x squared. That's going to be 5x to the 6th, 3x to the 4th, and 24, or 8 out of 24 is 3, and x squared is already gone. So there's that. I have 8x squared here. That's going to fall out. And my answer is what's left in parentheses. 5x, 6 plus 3x to the 4th plus 3. Okay. Easy peasy. All right, once again, I'm going to pull out 12x squared by cubed. All right, 12 times 9 is 108, so that's going to be 9. That's going to be x to the 7th, and that's going to be y to the 5th. All right, 12 goes into 72 6 times, so it's plus 6. I already have the x squared pulled out. And then I'm going to have y squared left over, minus 12 goes into 120 10 times. You got x cubed, and then y cubed already pulled out, so there's that. 12x squared minus y cubed. I'm going to cross that out. And I'm left with 9x to the 7th, y to the 5th, plus 6y squared minus 10x cubed. Okay. All right, moving on. Now, as we get to number 12, we are actually dividing these things. We are actually dividing these things, so be careful. We're doing long division. Okay, now in class, I seem to struggle with this a little bit, so let me just take it slow. You can pause, rewatch this as many times as you need to. You're gonna take what's in the bottom, kick it out, and then put what's in the top of the fraction underneath. Here plus 15x plus 54. Now, I don't care about anything other than the first term. I care about getting rid of that term right there. Okay, and I need to manipulate this term to get rid of this term. So every time I start this process, I ask myself, what times this term, x, gives me that first term, in this case, x squared. So what times x is x squared? Well, that's x, and I'm going to put it over the x term. And then that sets off a chain reaction in the sense that I only focus on getting rid of that first term to figure out what I'm multiplying by. But once I start multiplying, all right, then you have to multiply by the x and the 9. So that's going to be x squared plus 9x. Remember, when you do long division like this, you're subtracting this line. So the whole point in getting these two to be the same is that when I subtract, they fall out. Now, you do have to be very careful with your signs here. So you got 15x minus 9x, because you have to kick out. You got 15x minus 9x. You have to remember this sign here. Otherwise, you're going to be up a creek without a paddle. All right, so here, 15, 15 minus 9, it's going to be 6x. I'm going to bring down the 54. And then again, the process starts over again. So x times what is 6x? Well, that's 6. Okay, and so it's going to be 6x. 6 times 9 is 54. All right, I'm going to subtract. Everything's the same, so both terms will fall out. And this leaves me with 0. Now, when it comes to polynomials, there is no added decimal and keep adding zeros until it either is evident that it repeats or it terminates, or it is evident like pi that it just goes on forever. Now, so if I have a 0, I don't have, like, once I get through the end of my polynomial, I'm done. And so I either have a remainder or I don't. In this case, I don't, because I end up with 0. Once I got to the end, I end up with 0. And so my answer here is simply going to be x plus 6. Okay, now, hopefully you didn't find that too painful. Let's look at number 13. We'll set it up the same way, but there's one critical difference. Notice up here, I only have x cubed, and then I have a constant term. In order for all the math to check out, you must represent every power, starting with the highest, and going and representing every step down to the lowest term. Must represent every power. Okay, so I'm going to say 2x minus 1, and then I'm going to say 8x cubed here, and then I have 0x squares, 0 x's, and then minus 1. You have to do this for everything to work, for all the math to work out. So, all right, now to start the process, what times 2x gives you 8x cubed? Well, that's going to be 4x squared, and I'm going to put that over the x squared term. Okay, that tells me what I'm multiplying by. Now I multiply both terms, the 2x and the negative 1, by the 4x squared. All right, so let's do this one at a time. That's going to be 8x cubed, which is what I wanted. All right, and then that's going to be minus 4x squared. right? So that first term goes away. Now, you may be asking yourself, uh, that's a 0. How am I supposed to add or subtract to that? Well, if you're subtracting, adding's not really a problem. Oh, sorry. And then if you're subtracting, you can just make a negative. But notice, this is going to be a minus negative, so that's the same as plus positive. And if you need to make that slight change, you can. 4x squared, positive 4x squared. I'm going to bring the 0x down. I mean, technically there's nothing there, but again, I need the math to work out. So I bring it down. And then 2x times what is 4x squared? Well, that's going to be 2x. Okay, so that's going to be 4x squared minus 2x. Okay, first term falls out. All right, that's going to be, again, plus, it's minus and negative, so that's plus positive. And so that's going to be 2x minus 1. All right, what times 2x is 2x? 1. And so you can already see that this is all gonna jive. So I'm gonna subtract this, both terms fall out, and I'm left with 0. So because I'm left with 0, I don't have a remainder, and this is my answer. Okay. On 14, you did the exact same thing. I need to represent every power. I have to represent every power in order for the math to work out. So I'm gonna have x minus 2, x to the fourth, plus 0x cubed, plus 0x squared, plus 0x, plus 16. Okay. Now you have x times what is x to the fourth? Well, that's simply going to be x cubed. I'm going to put that over the cube. All right, so this is going to be x to the fourth minus 2x cubed. And then you just keep working. You can just keep trucking along. All right, first term falls out. All right, minus negative becomes plus positive. Okay, so there's going to be 2x cubed plus 0x squared because that you bring the next term down. Okay, what times x is 2x cubed? That's going to be 2x squared. Okay, so that's going to be 2x cubed when I multiply. All right, minus 4x squared. Subtracting, first term falls out. This is what I wanted. It's going to turn minus negative, turns into a plus positive. All right, so it's going to be 4x squared plus 0x. All right, what times x is 4x squared? Well, that's simply 4x. Okay, let's see, we got 4x squared minus 8x. All right, your first term falls out. That turns into a plus positive. Okay, so it's going to be 8x plus 16. All right, now you may already notice that I have x minus 2. So this is really close to working out where I don't have a remainder. But I'm going to need an 8 to multiply, and that's going to give me 8x minus 16. And so when I subtract, it's going to give me a plus positive. And so that's going to result in 32. All right, and I'm done. There's nothing else to bring down, so there's nothing else I can work to get rid of. So the last two, they didn't have remainder, so what was in the top was it. All right, because this does have remainder, let's talk about how to write this. This is going to be x cubed plus 2x squared plus 4x plus 8. And then you take your remainder and say plus 32 over what you divided by, x minus 20 or x minus 2. And that's it. That's all you do. That's how you do it. Okay. Hopefully, you find that I encourage you to work these problems both on the review and in the homework multiple times until you get comfortable with this. And remember, long division works every time. There's nothing that it doesn't work for, no situation. All right. But starting with 15, we can divide in a different way. But at the same time, when you divide synthetically, it has to be of a certain format. I can only divide by x plus a number or x minus a number. And the x could be any variable, but it has to be 1x plus a number or 1x minus a number. It has to be a simple binomial. All right, and that's just I'm not exactly sure why it doesn't work, but so like on number 13, we divided by 2x minus 1. If you try to divide that synthetically, it might work, it might not. It's not a guarantee. Okay, so let me do a couple things for you real quick. On 15, remember, you have to represent every power. So let's go ahead and write this out using every power. So we got x squared plus 0x minus 100. And then I'm going to take x plus 10. When I'm dividing by, I set it equal to 0. And I'm going to I'm going to move the 10 over, solve for x, and I'm going to get negative 10. Now, both of the items that I just did, or just wrote out here, are critical. is setting up your synthetic division properly. Synthetic division in itself is not difficult. You're working with coefficients, but you have to make sure everything's represented, and you have to make sure that you're dividing by the right thing. Okay, so let's draw our box. All right, I'm gonna take the -10 and stick it right out here. And then I'm gonna take the coefficients 1, 0, -100, stick them right there. The first one always just comes straight down below the line, so that's gonna be 1. And then all I do is say 1 times -10, and that's gonna be -10, and I put it right here. 1 times -10 is -10, and I put the answer right there. And then I start the process over again, but this time I add my columns. The first term is the only one that drops without anything else being done to it. And then the second column forward, you add your columns to get your new number. So this can be -10, and then you got -10 times -10, which is 100. So you have a -100 plus 100, that's going to be 0, right? If this number is 0, I don't have a denominator, or sorry, not a denominator, a remainder. So if that last number is 0, I don't have a remainder. So another thing is, let's look back real quick. I had x to the fourth. I divided by x, and my answer started with x cubed. That's so once again, I started with x to the fourth. I divided by x, and my answer was x cubed. So that's what happens here. I started with x squared. I divided by x. So when I write my answer, this is going to be x minus 10. Right? Again, because you're dividing synthetically using your coefficients. So what you get as your answer are coefficients of your new terms. And you start with x squared, you divide it by x, so your answer is going to start with x. It's always 1 degree less, right? On 16, it's a very similar situation. However, um, it's a very similar situation, but we have a much higher exponent with 4. So let's do x to the fourth plus 0x cubed plus 0x squared plus 0x plus 1296. And then again, x minus 6 equals 0. That's how we figure out what we're dividing by. So we're going to divide by 6. We got 1, 0, 0, 0, 1296. Okay. The first term always comes down. 1 times 6 is 6. And then from here forward, you always add your columns to get your new number. So this is going to be 6. 6 times 6 is 36. So that's going to be 36 when I'm adding 0. 36 times 6 is 216. So that's going to come down after I add 0. And then 6 times 216 is going to be 1296. Unfortunately, it was not negative. So I'm going to have a really big number. And because this last number is not 0, it's going to be my remainder. So this is my remainder. All right. So again, I'm done, but I need to write out my answer now. So this is x. I started with x to the fourth. I divided by x. So when I start my numbers, this is going to be x cubed plus 6x squared plus 36x plus 216, 16 plus 2592 over x minus 6. Okay. Okay, so there's my answer. Okay, now that should be the hardest part of the entire review slash test. So moving on to 17, we're dealing with negative exponents. When you have negative exponents, you have to, all it's telling you to do is change the position. And we can't leave, and I'm going to go ahead and tell you this because we're going to get there in a second. We're going to finish this thing starting with number 32, dealing with scientific notation. Scientific notation follows a different set of rules than what I'm about to tell you. Starting with 17, we can't leave things with negative exponents. That is not true with scientific notation because scientific notation is defined by positive and negative exponents. They mean different things, but it plays by a different set of rules. But if we're dealing with strictly exponents without scientific notation, then we can't leave it in negative exponents. So how do we contend with that? Well, here on 17, to make that -2 a +2, I have to change its position. So right now it's at the top of the fraction because remember, it's still understood to be over 1. So I drop it to the denominator, and now that exponent becomes positive. And it would work the reverse direction too. So like on 21, the negative exponent is already in the bottom. So to move forward, I bring this up and then I solve. So this is going to be 5 cubed is 125. So that's my answer here. Here, I have 1 over 5 squared. 5 squared is 25. So this is going to be 1 over 25. And that's my answer here. All right. Now let's handle take care of the rest of these. All right. So again, I would strictly focus on the negative exponent first. All right. So that's going to be 1 over -4 squared. And because the -4 is in parentheses, once I move it to the bottom, the square is going to take care of that negative, which means I'm going to have 1 over +16. Okay. Here we have 1 over -3 to the fourth. This time, this negative is not inside the parentheses with the 3. So the 4 only applies to the 3, but not the negative. So this whole thing is going to be negative, and 3 to the fourth is 81. Okay. Now here, because it's raised to the -1, this is going to turn into 1/7 plus 1/5. And then you're going to have to get common denominators. So let's move stuff around in just a second. All right. They both sides need what they don't have. The left side needs a 5, and whatever you do the bottom, you do the top. The right side needs a 7. Again, whatever you do the bottom, you do the top. Okay, so this is going to be 5 over 35 plus 7 over 35, which is going to give you an answer of 12 over 35. All right, which is your answer. Right. On 22. On 22, I would again take the moment, deal with the negative exponents. The 3 squared is going to come up to make it positive. The 2 to the fourth is going to drop down to make it positive. And that's going to be 9 over 16. Okay. Again, I would deal with the negative first. To make on 23, you're just going to flip the fraction to get rid of that negative exponent. So this is now going to become 2 to the fourth, which is just 16. Okay. All right. 24. On 24, the negative exponent only belongs to the x. So I'm going to bring the x up as x to the fourth and put it over 5. There's nothing else I can do. This is my answer. All right, like 22, we're going to do the same thing here. When we do that, we're going to have y to the fourth on top, x squared on the bottom, and then there's nothing else we can do. So that's our answer. On 26, I would multiply first before I do anything else. And so I would say x to the -10 plus 6, because when you multiply like bases, you add exponents. Okay, so that's x to the -10 plus 6. That's going to be x to the -4. At this point, I would then convert that into a positive exponent by saying 1 over x to the fourth. And there you go. All right. Now, on 27, you do the numbers first. So 32 over 4 is 8. And then you have more x's on top, on the bottom than you do on top. So that's going to be 3 more x's on the bottom. So 8 over x to the third. So there's that. On 28, you have, I would work with the numerator first, clean that up. And when you raise the power to the power, you multiply. So that's x to the 12th over x to the 15th. And then I'm going to clean that up. X over 12, x to the 12th over x to the 15th. That's going to be 1 over x cubed. Right. So there's that. All right. I'm going to do 2 things at once. I'm going to take the cube and apply it to that first parentheses. And then I'm going to take that second parentheses and bring it down to the denominator so I can take care of that negative exponent. So this is going to be 3 cubed x to the sixth over 2x. And then 3 cubed is 27. And then you're going to have x to the 6th over x. That's going to be x to the 5th. And there's nothing else I can do. So that's my answer. Again, you don't want to bite off too much at once. So do as much as you're comfortable with in a single step. And it takes as many steps as you need to. Right? Don't worry about that part. It just takes as long as it takes to get it right. And the more steps you do, the less likely you are to make mistakes, careless mistakes. So, right, don't be afraid to just add more steps. Now, on 30, again, I would work with the numerator first. That's going to be 4x to the 7th over 5x cubed. And then I'm going to simplify my x's, 4/5. And then I got x to the 4th up here. Okay, that's my answer. Okay, and then here, again, I would deal with the parentheses first. Inside, that's going to be y cubed, -2. And then I'm going to take care of the negative exponent. So it's going to be 1 over y cubed squared, because the negative all we did was flip the fraction. And then I'm going to apply the square. 1 squared is 1, and y cubed to the 6th. That'll be your answer. All right, now when it comes to scientific notation, all right, I'm going to write this 8.57. When the number is already in scientific notation, positive means right. Positive means you're going to move to the right. So 1, 2, 3, 4. And then negative means I want to move to the left. So 8.44. I'm going to move 4 places to the left. 1, 2, 3, 4. 1, 2, 3. Okay, so my new number on 32 is 85,700. So 85,700. That's my new number. And then my new number here is 0.0008. This is my new number on 33. And then on 34, we got 4.266. And I'll move the decimal 6 places to the left. So it's 1, 2, 3, 4, 5, 6 is the decimal. 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Okay. So there's that. Once again, if it's already in scientific notation, a positive exponent means I'm moving the decimal to the right. And if it's negative, I'm moving to the left. Now, it goes in the other direction when you're going from a regular number to scientific notation. So here we go. All right. Let's see. We got 414.988. Remember, the definition of scientific notation means the number in front of the decimal can't be 0 and it has to be less than 10. So number 1, 2, 3, 4, 5, 6, 7, 8, 9 are the only things that can be in front of the decimal. Okay. So 1, 2, and put it there. And so my new number is going to be 4.14988 times 10. And I moved it 2 places. So 2. I made a big number smaller. So it's a positive exponent. Okay. So there's that. I'm on 36. It's the decimal place lives right here. And so I'm gonna move it to here. So that's 1, 2, 3, 4, 5. 5 places. So my answer is going to be 3.16143 times 10 to the fifth. Again, I made a big number small, so it's a positive exponent. Okay, there's that. Right. Once again, the decimal place is right there. I want it here. So it's going to be 1, 2, 3, 4, 5, 6. Okay. So it's going to be 8.5 times 10 to the 6. 8.5 times 10 to the 6. Right. Uh, you'll notice on 35 and 36, I had a much longer string of numbers. And then on 37, I simply had 8.5. Well, you typically include uh, all the non-zero digits. Like on 38, there's a couple of zeros in the middle of it. I would include all that until there's a string of zeros. So on 38, it's 2, 0, 6, 0, 1, 2, and then I would cut it off. Okay, so uh, it just so happens that on 37, it says 8, 8, and 5, and then there's a string of zeros. I don't need that string of zeros in my answer. Okay, so just something to be mindful of. All right, right, the decimal's there. I want it right here. Let's count it out. Maybe 1, 2, 3, 4, 5, 6, 7. And I'm making a small number larger. So my exponent is going to be negative, and that's going to be 2.06012 times 10 to the negative 7. And it's negative because I made a small number larger. Small number larger. Okay. Let's see. I like that. Okay. On 39, remember the definition of scientific notation is that some number raised to a power of 10, but that number is it has a decimal, and that decimal, the number in front of the decimal can't be 0, and it can't be greater than 10. But it must be one digit and it must be greater than 0. So honestly, 39 kind of fits that bill. And I don't really want to move the decimal. So in scientific notation, how do you multiply by 1? Well, anything raised to the 0 power is 1. So we're going to take this number and multiply it by 10 to the 0, and that's the same thing as multiplying by 1, but now we're doing multiplying by 1 in scientific notation. Okay. Now, from now until the end, we're either uh, multiplying or dividing these scientific notations. So be careful. 5 times 4 is going to be 20, which is bigger than 10. So I'm going to have to account for that soon. right? And then when I'm multiplying like bases, I'm going to add the exponents. So I'm going to add the exponents to 10. This is going to be times 10, -8 plus 3. That's going to be -5. Now, that's a small number. And by taking this decimal and moving it here, I'm making it even smaller. So this is going to be 2.0 times 10 to the -4. Right? Moving on to 41, 2 times 3 is 6. So, and then times 10, you got -8 plus 7. We got 10 to -1. 6 is less than 10, greater than 0. So I'm good. I don't have to touch that anymore. All right. On 42, 16 over 4 is 4 times 10. And you're subtracting here. So you got -3 minus 9. So -3 minus 9. All right. So let's figure that out. That's going to be 4 times 10 to the -12. Okay. There's that. On 43, 35 divided by 5 is 7 times 10. -7 minus 1 is going to be -8. 7 is greater than 0 and less than 10. So that's good. On number 4, you have 2 cubed, which is 2 cubed times 10 to the -24, because when you raise the power to the power, you multiply. All right, well, that is the same thing as 8. And 8 is greater than 0 and less than 10. So that's that. I don't have to do anything else. Okay, and then the last one in this review is 5 to the -1. Well, 5 to the -1 is, we'll leave it like that for a second. So it's 10 to the -5. Okay, well, let's do a little side calculation. 5 to the -1 is 1 over 5, which has a decimal of 0.2. Okay, now, because we're done with scientific notation, we want to go ahead and take it all the way to the decimal. So this is 0.2 times 10 to the -5. I can't, I have a 0 in front of the decimal. I can't have that. So I'm going to take this, move it here. And earlier, I moved it on 40, I moved it left 1, and that meant I added 1. Okay, so I'm going to do the opposite here. I moved it to the right, so I'm going to subtract 1. Right, so my final answer here is going to be 2.0 times 10, 2.0 times 10 to the -6. Okay, uh, please watch this, practice as much as you can, and bring all your questions for review day, and I will see you in the next video.